1. So assume that by the time I move to the y of n minus 1, I already know the t. So thinking about the stock market, I'm sitting at n here, I know everything up to now, including today. I'm not making the prediction for tomorrow. Okay, so I know d, right? So it's like, it's very like, you know, you make an algorithm to predict the stock markets of the next day. And you know, in the morning, you compute, well, yesterday you make some algorithm, and you predict what the price of today will be, right? And then today you come in, you find some error, and that error allows you to prepare and adjust the filter so that you can compute for tomorrow. Right? So today we have all these things. I replace it by this. And also R, replaced by this R here equal to this. Instead of taking the expectation now, I simply take all of this value. So xn, and x of n, x of n minus 1, and so on. So I replace this by those matrices. Can you see that? So if that's the case, then we can write the adaptive equation now. The adaptive equations. And then I need to write one more equation and then I let Kim to run. And that exercise. So by replacing that, I get a very simple formula of LMS. Formula here is h of n plus 1 is equal to h of n plus now 2 mu times mu, and then I have to find out the error of n and come with this vector x of n. That's LMS updating formula. Because you see this thing here, when you subtract this, what it can get is the design subtracting this output. I like to run that. I told to show this thing here is like the convolution, does that give you the output, and this is a design subtract like this. Okay, so I asked you at home to adjust and show this. Okay, so this equation here, and in full, what it is h of n plus 1, that filter. X sample here based on the previous sample, look at this error, and then look at the previous input, the previous input. Okay, so now can you have to connect the projector?
Yeah, sure.
I take this signal and I got Y. So I let the system run, I got Y, and someone outside here tell me that, the design output is this. So, you know, like you have let the child make something, and next to him or her, it's tell, okay, that's good, that's bad. So you tell the child this design. And what you're telling the system here is the arrow function. If you take the arrow function, the child will take the arrow, the mistake, and it adjusts the behavior of the filter. So now the child will know how to move next time. Can you see that? Right? So here is the arrow here, multiply with that, directing you and get with the next filter. Coefficient. Okay. Alright, so here is algorithms, right? So it's similar like what we have here. You have this filter is the filter now, and you have to update the next one. So I have 2 mu here, and this minus is giving you the error, and this is the x here. Okay. So we can run now. What is the next? So the system I want to show here is I take x, and x is just simply I filter the signal x, so this command filter in convolution. The filter has three terms. One, 0.9, 0.4, and take with the random signal. So maybe you want to plot out a signal. Okay, so now is the signal. This signal is taking a white noise. So we're taking the white noise and filter it and get this output. So now assuming that I have the signal, which now I can model. The filter that came to show now is, I have a signal. You can see that signal randomly wide. Maybe you can zoom in a little bit. So you can zoom in here. Give me a little bit. So you can see the sample very extremely rapidly. And the algorithm we want to do now is, let's say that this is like maybe the stock market, VN index. Okay? And it has some model there. Actually, the model that signal, maybe I can write here, is equal to, can you go back to that? X of n equal to 0.9 x of n minus 1. Because this filter here, and remember, if you do the filter, this representing the D and this representing the I, right? So that is 0.9 here plus 0.4 x of n minus 2 and plus the random variable which is Wn. So this thing here is a random noise. So think about the stock market, the stock market of tomorrow is taking about 90% from the yesterday and 40% of the day before yesterday and something else, some noise. So that, and create the signal you can just see. The problem is now is giving that signal. We say now we have a signal now. We have to vary rapidly. And we want to make a filter now taking all the sample before and predict what the next one will be. Because you see prediction, if I can, without this noise, if I can find out those two ways, then I can use that to predict the next one. Okay. So using that, maybe we can just run the filter with only two terms. So at first, I'm going to start with the filter A0 equal to 0. Right? And let the system run. You can go back. So the filter is 0, 0. And I have several instances of that filter. And I take the filter, so the filter, remember, I just take this transpose down this. Right? So the x of previous, and then minus 1, so this is x k minus 1, k minus 2. And I take that and I multiply with this. So I have this and I get that predictor. And when I got this signal, I can now find the error. That is error. And I use that error, I put this error here. And together with the signal, and this is just mu, and I can update them to get this edge. Right? Can you see that signal? So now, when I run that now, I'm going to plot out the filter because so plot out the filter. So you can see I plot the filters. X edge. Okay. So the filter edge is initially I start two things are equal to 0. Right? And the filter has two coefficients. So the edge here, at the instant n, we have a k equal to 0 and 1. I have two constants, two filters. And then I let the filter run. So these two coefficients, without the first instant, they have these two numbers. So first is everything 0, and next time is some value and so on, right? And the filter adapt will adjust. And what you see is slowly, very quickly, out about 2,000 samples. You see the thing converge roughly here. So you find something 0.4 and something about 0.9 coming out here. So you see that adaptively and adjust, right? So it's really like take some value before you get some error. The error will allow you to adjust the filter, and very quickly you got something like this, conversion. So now imagine if I take the cell phone, and this is about 2 milliseconds. So very quickly the system adjusts and let me talk to my friend. And now let's say I'm driving a car, when you move to another environment, the thing changes, this thing will slow down and change. Right? So you see that. Very simple. Here, make it show by the MATLAB